This lecture, we're going to talk a little bit about what are forces and how do they fit into the concept of framework. And you've certainly heard this word before. Someone forced someone else to do something, or, it took a lot of force to slide a desk. But this is actually a relatively recent concept compared to how long people have talked about stuff. Only really in the time of Newton did the idea of a force become really important in the idea of physics. How much force does it take to do a job like sliding this desk sideways? And before we can jump into something like that, we actually have to understand what is a force. And we're going to define a force as the unit of measurement required to accelerate 1 kilogram of matter by 1 meter per second squared. And because we can multiply units together, this ends up coming out as force is measured in kilograms, meters per second squared. And that's a real pain to write out. So there's a new unit called the Newton. 1 Newton, and for short, is the unit of force. And that's because almost all of Newton's laws, actually all of them, had to do with the concept of force. So it was really a very, very important breakthrough. You'll start to see why in the next several videos or so. But for now, let's just look at what we know about force. So to start with, force is defined as kilogram meters per second squared. It's also a vector quantity, so we put a little arrow over the top of it. So that means force is measured not only in terms of a magnitude, but also in terms of a direction. So 10 newtons of force going north is not the same as 10 newtons of force going south. And why is this? Well, if you have a heavy bookcase and you hire someone to move it, but they move it to the wrong side of the room, they haven't really done you any favors. They maybe applied the total amount of force you wanted them to, but if you wanted them to apply it in the opposite directions, you're out of luck. So applying a force left is not the same as applying a force right, north, south, etc. And because of this, what happens when there are multiple forces? It's actually pretty easy to have this happen. For instance, let's say a couple people are trying to move something big and heavy. Let's go back to our desk example. So here's an overhead view of our desk, and here's person 1 and person 2. And they're both pushing, and they don't want to get in each other's ways. So they're starting at the corners and pushing in. Well, we can't just add their forces together exactly. That wouldn't make any sense. I mean, to take a more extreme example, 2 people pushing against each other. Even though they're both pushing, they're pushing in opposite directions. So we can't just add the 2 forces and say, 10 newtons plus 20 newtons is 30 newtons, and then pick some random direction. Instead, we have to add them together using vectors. And hopefully by this point, you've done a little bit of vector addition. If you haven't, it's not a big deal, but it is something that is very important to know for a lot of physics. And the basic idea behind vector addition is parabolas, which I know is an odd thing to base an entire idea of math on, but it's what we have. And the reason you have parabolas is you draw both your vectors. So let's call it force 1, force 2, remind ourselves they're vectors. The way you complete this is you make a parabola. So we have 2 parallel force 2's, 2 parallel force 1's. And then we draw a new vector from the starting corner to the new corner. And that's our new force. That's the sum of forces. The sigma here means sum of. So we're summing up all of our forces. In both direction and magnitude matters. So if force 1's really big, and force 2 is really small, we're going to see how that comes out when we add them together. So magnitude matters, but so does direction. If force 1 went left instead of right, we would see a completely different new sum of forces vector. So there's a lot of different ways you can sum forces together, and we'll go over them in next lecture to make sure you have a firm grasp of how you do it.